Okay. Yes. We welcome you to PSSB, Physical Sciences Silver Bullet, with me, Richard, here. Yes, we are looking at this question. It says that predict the shape of the molecule with the following properties by feeding the table below. Okay. What do we have here? Number of bonding pair of electrons. Okay. What do we have here? Number of lone pair of electrons. And this side you have geometry or shape of the molecule. Okay. Let's start and look at the first one. We have how many? One bonding pair. And how many lone pair? 0. What geometry do we get under the circumstance? The geometry is linear. Okay. Then we come to the second one. How many do we have? We have 2 bonding pair of electrons. And we have 0 lone pairs. What's the shape? Still linear. Okay. Then we come to this. How many bonding pairs? 3. And how many lone pairs? 0. What is the shape? The shape is trigonoplanar. Okay. Then we come to this one. We have 4 bonding pairs and 0 lone pairs. What shape is adopted under that circumstance? It's tetrahedral. Okay. Okay. Then we come to this one. We have how many? 5 bonding pairs and 0 lone pairs. What shape is adopted there? It is a trigonobipyramidal. Okay, we come to this one. How many do we have? 6 bonding pairs and 0 lone pairs. What shape is adopted under that circumstance? It is octahedral. Okay, we come to this one. We have 2 bonding pair of electrons and 2 lone pairs. What shape is adopted? What shape is adopted under the circumstance? It is bent or angular. Okay. Then we come to this one. We have 3 bonding pair of electrons and 1 lone pair. What shape is adopted under that circumstance? It is a trigonopyramidal. Yeah. Then we come to this question. It says that consider each of the shapes or geometry of covariant molecules below. For each of the geometry, state whether there is presence or absence of lone pair. Okay. 2, write the number of bonding pairs. 3, write the shape or geometry of the molecule. Okay. Yeah, let us start with 1. Okay. Do I have a lone pair here? The shape shows that there is no lone pair. I want to tell you that a lone pair would push all these bonding pairs downwards. So the shape indicates that there is no lone pair. So answer is no lone pair. The shape shows that the way they are spread, it means that they are not being pushed by any other invisible force. Okay, we come to number 2. It says that write the number of bonding pairs. Okay, what do? We count 1, 2, 3, 4, 5, 6. So the answer is 6 bonding pairs. Okay, then we come to number 3. What is it? Write the shape or geometry of this molecule. Okay, so what is the shape? Okay, it's not, but I want you to remember that what you have here, it combines like this. We have this one bonding like this to form some kind of like a square. Then each point of this square links to the atom above and links to the bottom below. When that one is done, the shape we get is called octahedral. It will have 8 faces. Yeah, then we come to this one. Okay. Yes, the way it's arranged, you have to actually these bonding pairs curving downwards. Okay, let us start by answering the questions. So number 1, state whether there is presence or absence of lone pair. Okay, the answer is there is a presence of lone pair. Okay, how do you predict that? We predict it from the fact that these bonding pair are being forced. So the force which is forcing this to curve is an invisible force, which is a lone pair. So let's go to the next one. Okay, what does it say? Write the number of bonding pairs. So we have 2 bonding pairs. Then we come to 3. It says write the shape or geometry of the molecule. What shape is this one? It is bent or angular. Yes, so we come to this shape. Okay, and we see the distribution of the bonding pairs. Okay, the first one says state whether there is presence or absence of lone pair. When this question comes, actually they are talking about the central atom, whether it's having lone pair or not. So what can we say about here? The distribution shows that there is no lone pair. So answer is no lone pair. The shape shows that there's nothing pushing these bonding pairs. They are spreading out. So let us go to number 2. What does it say? Write the number of bonding pairs. Okay. This is 1, 2, 3. So the answer is 3 bonding pairs. Okay, then we come to number 3. What does it say? Write the shape or geometry of the molecule. So the way they are spread and they are 3, what is the shape? The shape is trigonal planar. Yeah, so then comes this molecule. Okay, and we are seeing the bonding pairs being distributed around. And the question says that for each of the geometry, state whether there is presence or absence of lone pair. Okay, the way these bonding pairs are distributed, our assumption that there is something pushing it, which is here. You see they are curving towards each other. So whatever is pushing it must be a lone pair. So we have a lone pair. So there is a presence of lone pair. Okay, then you come to the second one. Write the number of bonding pairs. So how many are they? 1, 2, 3. So the answer is 3 bonding pairs. Then we come to number 3. The shape. What is the shape of this molecule? The shape is trigonopyramidal. It's a pyramid. These 3 are sitting on the ground. Okay. Yeah, then we come to this molecule. Okay. Yeah, we are seeing the bonding pairs being distributed the way they are. So in this case, I want us to assume that we are having a triangle in the middle linking each of these bonding pair links with the one up and with the one below. So in other words, we are having 2 pyramids, one going up and one coming down. So to attain that shape, do I have a lone pair? The answer is no. So the first answer is no lone pair. Okay. Then you come to question number 2. Write the number of bonding pairs. 1, 2, 3, 4, 5. So they are 5 bonding pairs. Okay. Then we come to number 3. Okay, write the shape or geometry of the molecule. So what is the shape of this molecule? Because it has a triangle up and a triangle down, we call it trigonal bipyramidal. Yeah, let me try and show you. This is the triangle in the center. So each of these atom links with the one up, and each of these atom links with this one below. You're going to end up having 2 triangles, one up, one below. That's why the word bi comes in. Bi implying 2. So the shape is trigonobipyramidal. So then comes this molecule with the bonding pairs distributed as shown here. Then the question says, state whether there is presence or absence of lone pair. What we can, where the bonding pairs are distributed, they show that there is nothing pushing them. So, in other words, they are showing that there is no lone pair. Nothing's pushing them, they are spreading freely. Nothing's pushing them, they are spreading freely. So we come to the second question. Write the number of bonding pairs. It's 1, 2, 3, 4. So we have 4 bonding pairs. Okay, then we come to the last question. What does it say? Write shape or geometry of the molecule. What is this geometry? It is tetrahedral. So with that, I would like to say thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet, with me, Richard, here. We urge you to subscribe, to comment, to like, to share. And we need to remind you that this channel, Physical Sciences Silver Bullet, specializes in physical sciences, grade 12, 11, and 10, and natural sciences, grade 8 and 9. We recommend that if you are using our channel, use the playlist. So if you are grade 8 and 9, just look for natural sciences grade 8 or natural sciences grade 9. For grade 11 and 10, look for physical sciences grade 11 or physical sciences grade 10. As for grade 12, each chapter is presented independently. So just look for that chapter of your choice and click on it. There you'll have all the material which you need for the course. With that, I would like to say thank you. We appreciate you. Stay blessed. See you next time. Bye-bye.